Serverless cloud computing is almost a decade old. While most thought it was going to be a revolution in how we consume cloud services, that's not how things turned out. Let's talk about it. So welcome to the Cloud Computing Insider. If you're new, my name is Dave Linthicum, a cloud and AI SME, best-selling author, speaker, tech influencer, and experienced technology executive. Let's get going. So serverless cloud computing has matured, but not necessarily into the simple low-friction model the market originally promised. So AWS, Microsoft, Azure, and Google Cloud all offer credible serverless platforms now, yet each wraps convenience in proprietary tooling, pricing complexities, and operational assumptions that can become liabilities at scale. So I still see the real value in serverless for event-driven systems, APIs, automation, and some AI workloads, but also see too many enterprises adopting it with weak governance and unrealistic cost expectations. So developers like the speed, but the speed without discipline often produces fragile architectures. So in my view is that serverless works best when used selectively, measured carefully, and governed far more aggressively than most teams expect. So I've been tracking cloud computing serverless stuff for a long time, since AWS's Lambda showed up, and let's give them credit. They defined it as to what it is, and I'll explain to you what serverless means in a minute. I also have a course on serverless computing. It's out on LinkedIn Learning. I think it's in its 4th iteration now, just recently published an update about a year or so ago, and I'll go ahead and put the link up here if you want to take that course. But there's plenty of courses out there and plenty of information on what serverless is and how it works. And I suggest that if you're going to be in the cloud computing game, which I think most of you are, it's a good idea to get smart about what serverless is, what it does, where it fits, and how it fits into an architecture, most importantly. So the best way to tell you about serverless is kind of walk you through an example. So let's get to it. So first, we request or event arrives, a user action API call or system event triggers the serverless workflow. Next, the platform routes the event. The cloud platform validates the trigger and routes it to the correct serverless function. Next, the function runtime starts. The platform either starts a new runtime environment or reuses an existing one to execute the function call. And the next step, the function does the work. The function runs its business logic and interacts with services like databases, storage, and external APIs. And finally, response and monitoring. The function returns a result or admits new event without platform, captures logs, metrics, and execution data. So at its essence, what serverless is, and it's kind of a little bit of a confusing thing because it doesn't mean we're not using servers, we're still using servers. It just basically frees you up from having to allocate infrastructure. So in other words, if I'm going to run something, typically in a cloud environment, I'm going to have to figure out the number of compute servers I'm going to need, the storage I'm going to need, memory I'm going to need, operating system, types of processors, all that kind of stuff. Well, within a serverless environment, I just go ahead and make a function call, and it's able to figure all that stuff out on the back end. And by doing that, it frees me up from, having to size my application in terms of the amount of infrastructure that I'm going to need. And obviously, if I'm overestimating that, I'm going to spend too much money on infrastructure that I'm not going to really use. And if I'm underestimating it, the application is going to run out of resources and things are going to fail. So serverless kind of removes you from that, which is kind of cool. However, it's not free. Obviously, if you're turning over the infrastructure allocation to another process that you don't control, you don't know if it's over allocating that process. And typically people complain to me often that they view serverless as being, even though it's fairly convenient, it's costing them more money, even though it frees them from not having to, figure out how to size the infrastructure. Having an automated mechanism do that for you isn't always going to be cheaper. And so serverless has kind of mixed reviews as to whether or not, number one, it's easier than non-serverless environments, and number two, it saves you money. So let's kind of look at where serverless is now, or the state of serverless, and how it's kind of evolving in 2026 and 2027. So AWS Lambda, together with AWS Step Functions and Amazon EventBridge, is still the most complete serverless stack in the market right now. But it also makes it far too easy for enterprises to build tightly coupled architectures that developers later struggle to observe, govern, and unwind. So I hear that as a common complaint. People are leveraging serverless to build, many of their applications, And it certainly has some core capabilities that allows them to do that. It's a good system at the end of the day. However, it's only applicable in particular narrow kinds of problem domains. And many times I'm seeing people overuse it, and ultimately they run into issues around how they're going to observe it or provide observability to monitor it over time, how they're going to govern it, because you have to have governance systems that are able to see inside these serverless-based functions and unwind, different transactions. So Azure Functions and Azure Container Apps and Azure Logic Apps give Microsoft a stronger enterprise serverless story than many people admit. But I remain skeptical of how often that flexibility simply translates into more moving parts, more configurations, and more operational ambiguity. So again, Microsoft, following AWS's lead with Lambda, provides a serverless system as well. They call it Functions and Azure Functions. And it's fairly capable. It does, what Lambda does on AWS, but, ultimately it has some limitations. It becomes overly complex in terms of the way I see it. More configuration is going to be needed. And when you operate it, there's going to be some complexity around the operation stuff, where people find it, basically I hear the word with Azure Functions, more trouble than it's worth. And so you can take that with whatever you want to take it. I would test it with your particular use cases and how you're going to use it in the application. Your mileage is definitely going to vary, but I would look out for that specifically. So Google's serverless solutions, Google Cloud Run, supports the Eventarc and Google Cloud workflows, and it's probably the cleanest serverless experience for many modern workloads. It's pretty good environment. You got to remember, they showed up after everybody else, so they just kind of build stuff on the mistakes of the other folks and make sure they don't make the same mistakes. But the enterprise should not mistake a polished developer experience for proof that it's automatically the best long-term platform fit. So again, pretty much the same sort of limitations and problems you're going to have with the other serverless environments from, AWS and Microsoft. You're going to see the same sort of thing in Google Cloud Run as well. I view it as a cleaner environment. It seems to be less complex, whatever that means to you. But again, you're going to have to look at your application requirements and look at this particular serverless implementation and see how it fits. And it's going to be that kind of analysis for all of this stuff. In other words, if you're using a particular platform, and normally we're going to pick a platform before we pick that we're going to move to serverless, in looking at moving applications into a serverless framework, you got to consider everything we just talked about, the complexity of it, the operations, the security, the governance, all that kind of stuff is harder to do in a serverless environment. And giving up control of the infrastructure may be something that's good because we don't have to deal with that on the back end anymore. But in doing so, we may be, cutting off our nose to spite our face in many instances. And you developers know what I mean. So I do not consider AWS Lambda, Azure Functions, and Google Cloud Run interchangeable because each one imposes different assumptions around scaling, networking, identity, workflow compensation, and integration that can become difficult and expensive to reverse. So they basically all have the same sort of issues, plus or minus 10, 15%, again, based on your requirements. But they also bring a lack of interchangeability. So serverless is going to come with lock-in. Now, many in the serverless world will push back on that. They'll talk about different open systems and, common application code frameworks, things like that. I get it, but if you're going to build something on a serverless platform, you're not just using a particular language to code it as much as you are, marrying to enabling technology and an architecture. That's going to lock you into that particular serverless implementation. So if an enterprise says it's doing multi-cloud with Lambda functions and Cloud Run, simultaneously, I usually assume the real story is, duplicated complexity and less security, observability, governance, and deployment discipline have already been standardized, above the platform layer. So in other words, if you're going to do this and you're going to figure out how you're going to do portability and you're going to look at putting common, control planes across the different serverless platforms, security, governance, operations, things like that, things are going to be important to running an application. You put a lot of pre-thinking architecture into how you're going to deploy your serverless system, which is going to provide you a a bit more flexibility in your ability to kind of, run things and move things across the environments. But unless you do a tremendous amount of planning, that's not going to happen. And so far, in the 15 years I've been doing cloud architecture and building and deploying cloud systems, I haven't seen people do it. So they never put the planning involved. So in other words, the serverless, or the ability to pick serverless, is kind of an ad hoc need. They go ahead and move in that direction because they view it as the path of least resistance. And without the planning that occurs, you're still going to have portability issues. You're still going to have operations issues, security issues, and governance issues across the different platforms. At the end of the day, when you're using the serverless systems, you're going to be building a silo. So on AI-enhanced serverless, I see AWS Lambda being paired with Amazon Bedrock, Azure Functions, and Azure Container Apps, aligning with Azure AI Foundry and Google Cloud Run, connecting naturally with Vertex AI and Gemini. But managed AI plus serverless often introduces new latency, concurrency, and cost problems rather than eliminating the old ones. My recommendation, if you're going to be doing AI, you're just overcomplicating your architecture if you're introducing serverless. Now, if there's an application need for it that can't be, met any other way, it's perfectly fine. But if we're trying to bring as many buzzwords as we can into our AI architecture, typically serverless isn't one where I'm going to die on that hill. In other words, I'm going to try to keep my AI architecture as simplistic as possible and take the simplest approach to solving the application issues, solving the business problems. While serverless can be a part of it, you got to kind of ask yourself, should it? In many cases, no. So my bottom line is that real decision is not Lambda versus function versus Cloud Run, but rather the surrounding workflow and integration services such as AWS Step Functions, Azure Logic Apps, and Google Cloud Workflows generally fit the workload well enough to justify their abstraction overhead and lock-in risk. That's what it comes down to. In other words, serverless is fine. Great enabling technology. It works well. It's been out there for a long time. They had a rough start when Lambda first started. I remember writing about that many years ago and AWS being mad at me for it. But they fixed it and it functions well. And many companies, run billions of dollars of infrastructure on it each and every day. You just have to consider the trade-offs. In other words, there's not a free lunch when you move to serverless. You have to consider the complexity it brings. You have to consider the overhead. You have to consider the cost. In many cases, it's going to be additional money for building and deploying serverless systems. And the big one would be the lock-in risk. In other words, if you're moving to serverless, I don't care what language you're programming in, the operating system you're using, whatever, you're going to be locked into that platform because you're obviously building functions using the approach of that serverless ecosystem. And those are very different to move into other ecosystems, if not impossible. On cost, AWS often looks inexpensive at small scale, but can become surprisingly expensive once Lambda, Step Functions, EventBridge, and supporting data services start compounding. Azure can be cost-effective for enterprises already committed to Microsoft, the Microsoft ecosystem, but often hides cost and architectural complexity. And Google Cloud can look efficient with Cloud Run for bursty and container-centric workloads, but still demand strict discipline around traffic, networking, and AI consumption if teams want the economics to hold true. So they all have pluses and minuses. And you knew I was going to say that. It's the it depends thing. It depends on what you're doing with it. It depends on the platforms you already selected. And it depends on the skill sets you already have around. In other words, if you're already into Microsoft and you're a Microsoft shop, obviously Azure is going to be the path of least resistance. Same with Google and same with AWS. And if you're using all three, though, however, different ecosystems of multi-cloud deployment, you need to look at the benefits and the cost trade-offs of using the serverless environment. My take and my advice to people who are looking at serverless is I would assume it's not a fit and then make it prove to itself that it's going to have some sort of a value. Because many times people move into the serverless world just kind of a knee-jerk reaction as to this is what they need and this is going to solve many of their problems. This is going to simplify the way in which they deploy and operate applications when nothing could be further from the truth. It's going to add complexity. It's going to add, the ability to build silos, which you want to avoid, lock in, and just overhead on top of the way in which you build deploy applications. So it has to have a functional need. It should have a business case that can be made around the use of serverless. And you need a good architect to go figure out what that is and how it works holistically with the rest of the systems that are there. You got to remember serverless unto itself may have a little mini economic advantage in its little fiefdom. However, look holistically in terms of how the serverless system interacts with other systems within the enterprise. And in many cases, you'll find that what seems to be a good idea in the narrow is not a good idea in the wide. Well, anyway, let me know what you think about serverless, whether you guys are using it or not, using it successfully. Changed my mind in terms of my, take on serverless here. I'm certainly open-minded about, how other people are being successful with this stuff. And we'll see how it evolves, in 2027, 2028. I'll be keeping an eye on it. Don't forget to like and subscribe and check out my other videos on this channel. Also check out my InfoWorld Cloud Computing blog, my 100+ LinkedIn Learning courses, and of course my Generative AI Architecture course out on Go Cloud Careers. And finally, my latest books, Unlocking the Power of Cloud and An Insider's Guide to Cloud Computing. Finally, make sure to check out my other YouTube channel, Dave Linthicum is Not AI. The link is in the description. So until next week, stay very, very safe. The magical YouTube algorithm thinks this is another one of my videos that you should watch now. Take care, guys.